Hello, Algebra 2. All right, we're starting a new week. I sent you an updated calendar. Hope everybody had a nice Easter, Passover, whatever you were celebrating this past weekend. It is the 14th, but maybe some of you are getting a jump ahead doing this on the 13th. But we're doing Unit 4, lessons 1, 2, 3, Unit 4, the beginning of exponential. All right, here we go. So, first question, we got f of x is equal to x to the negative 1/4. Which of these could be equivalent? So, two things going on here. So, let's do a quick review. We got this thing called the power root. So, that's the power, that's the root. So, like if I had x to the 2/3, that means I'd have to take the cube root of x. And I'd also have to square it. You can square it on the inside or square it on the outside. So there's an example of the power rule, power and root. So on this one I got 1/4, but what's that negative mean? That's another concept. So what's a negative? Like a -3. If I had x to the -3, I'd say that's 1 over x times x times x. It's repeated division, not repeated multiplication. So it means divide. Okay. So what does this mean? X to the negative 1/4. It means I got to divide. And I got to take the 4th root, raise it to the first power. So I'm going to take the 4th root. And then you don't have to worry about raising it to the first power. So I'm looking for this answer. And that is choice 3. Okay. Which of these is equivalent? All right, so I got, I just did it. X to the negative 3rd is 1 over x cubed, right? 1 over x cubed. So what a happy coincidence. 1 over x cubed, I can rewrite that as x to the negative 3. Raised to the 2nd power. What do you do when you got power raised to a power? Hopefully you remember you multiply those together. So you get x to the negative 6. All right, and well, there it is. Choice 4. Okay. Here we go again. 5 halves. 5 halves. 5's on top, 2's on the bottom, so 5. Let me rewrite that because it's hard to see. There's my power. There's my root. So this is take the square root of a, raise it to the 5th power. Take the square root of a, raise it to the 5th power right there. Choice 1. Okay. So some basic rules of exponents. Now we're moving on to functions. We're looking at an exponential function. It's growing. Remember that? Growing exponential. I don't know about you, but I've seen a lot of these exponentials with the whole coronavirus talking about exponential growth, and we gotta, eventually make it stop at the apex. So a lot of math going on there, but we'll see that in this lesson too. All right, which of the following expression represents the graph shown? So it's growing, so I know the base, right? The base has to be bigger than 1. B has to be bigger than 1 if it's growing, okay? And it has to look something like this, a times b to the x power. So some of these we're gonna cross out, let's see. So it's growing. Oh, and another thing here, it looks like it's hitting here at 3. So when the input is 0, the output is 3. So we can eliminate a lot just on that. Input 0, do you remember that 5 to the 0 is 1? So that can't be it. Input is 0. 4 to the 0 plus 1 would be 1 plus 1, which is 2. So that can't be it. Input is 0. Anything to the 0 is 1. So 1 plus 2. This is 3. That could be it. This one, input 0, 3 to the 0, plus 2, 1 plus. So it could be either 3 or 4. But this one would be decaying because the base is less than 1. This one's growing. So this is a decay. And this is a grow. And this one's clearly growing. So it must be choice 4. All right. Next one, we got a growing exponential function, which the following is the y-intercept. Oh, so just like I was doing a minute ago, plug 0 in. Let's see what we get out. 5, 2 to the 0, plus 7. Anything to the 0 power is 1. So I'm going to get 5 plus 7, which is 12. Choice 3. All right. Next page. All right. Hopefully these look easy. So I'm looking for the exponent. See, this is a power of 2. You got to know your powers of 2. What are your powers of 2? Well, 2 is a power of 2, 4, 8, 16, 32, 64. You can save yourself a lot of time by knowing the powers of 2. So I can see this. Oh, that's 2 to the 4th power. So what is n? Well, it's down here, so it must be a negative number. Negative 4. It's the 4th power, but it's repeated division. All right, there's a power of 5. Hopefully you recognize that. That's 5 to the 3rd power. So n is 3. Base 10. 1, 2, 3, 4, 5, 6, 7. 7 zeros down there. So this is 10 to the 7th power. So the base must be negative 7 again because we're dividing. And then anything raised to the 0 power. Anything raised to the 0 power is 1. Okay. All right. Which is the following without the use of calculator. All right. So what does that mean? I got to take it's that power root thing again. Power root. Okay, so the root is 4, and the power is 3. Well, I just wrote down the powers of 2, so you can see right there, 1, 2, 3, 4. So if I take the 4th root of 16, I'm going to get 2. 4th root of 16 is 2, and then 2 cubed is 8. You could check it with your calculator, but you should rewrite it first. This is what I'll be looking for. All right, this 1 over the cube root of 27, and then we got to square it. So besides powers of 2, the other one that comes up a lot is powers of 3. 3, 9, 27, 81. Those are the ones you're going to see. So this one's 27. Cube root of 27, 3, and then I got to square it. So I get 1/9. Last one. Again, you should try some of these on your own. Pause the video. Try it, but I'm just going to go ahead. Negative, so it's going to end up down here in the denominator. I'm going to take the cube root of 8, and then I got to raise it to the 5th power. Well, the cube root of 8 is 2, and 2 to the 5th power is 32. There it is. 1, 2, 3, 4, 5. There's 2 to the 5th power. 32. All right, simplify. This kind of work I want to see. All right. Simplify each expression completely. All right, I'm just taking the x and raising it to the negative 2 power. So that 3 is happy to be up there. The x is going to move down. That's all. On this one, it's the difference. Now the whole thing is going to move down. So the 3 and the x go down. And I got to square it and then simplify it. So that's going to be 9x squared. And this last one, the whole thing is going to move down. I'm going to take the square root. The whole thing goes down. And we're going to take the square root. So what do you get? Square root of 4 is 2, and the square root of x squared is x. All right, number 9. Consider this function, 2 to the x. Fill in the table below. If you remember, you could start with 0, because anything raised to the 0 power is 1. 2 to the 1st power, 2. 2 to the 2nd power, 4. 2 to the 3rd power, 8. And then these numbers are just reciprocals. So this is 1/2. This is 1/4. This is 1/8. Plot these points. All right. So we got 1, we got 2, we got 4, we got 8. What's happening? It's growing exponentially. Keep going. On the other side, I got a 1/2, then I got a 1/4, then I got an 1/8. Remember, it never touches the x-axis. It gets closer and closer. And we like this function, because it's a nice example of a one-to-one function. It's 1-to-1, which is going to lead into our next big topic eventually. Because it's 1-to-1, it's going to have an inverse. That thing's called the log function, the logarithmic function. Is this function? What makes this function decay? Oh, I'm sorry. That's a mistake. What makes this function grow? What makes this function grow or increase? The base is greater than 1. Base is greater than 1. That's what makes this thing grow. Okay, well, that's it. So you've got a couple pages to do. There'll be very similar questions. You got the independent work. Looks like 5 multiple choice. Not a whole lot of work to show on 6, 7, a little bit of work, 8, a little bit of work. Number 9, number 10, a little bit of work you're going to show me. And that's it. All right. Be safe.